Lesson 4.6, Geometric Sequences. A geometric sequence is a sequence of numbers whose successive terms differ by a constant multiplier. A common ratio, r, is the multiplier for that geometric sequence. So for example, if I started out with the number 1, and I multiplied it by 2, then I multiplied that by 2, I multiplied that by 2, I multiplied that by 2, this would be a geometric sequence because we're multiplying by the constant multiplier or the common ratio, which is 2. Everything was being multiplied by 2. Write the first 6 terms of this geometric sequence in which a1 is 1 and r is 3. That means when we're doing this sequence, we are going to take every number in the sequence and multiply it by 3 to find the next number. Pause the video for 1 minute and see if you can finish solving the pattern. So our first term is 1. We multiply it by 3, we get 3. Multiply it by 3, we get 9. Multiply it by 3, we get 27. Multiply it by 3, we get 81. Multiply it by 3, we get 243. That would be the first 6 terms in this sequence. Now, in this sequence, what we would like you to do is find a1, r, a sub 3, and a8. So a1 is the first term in the pattern, so a1 equals 2. The common ratio is the number we're multiplying by to get to the next term. So what do we multiply to go from 2 to 6, from 6 to 18, from 18 to 54, from 54 to 162, 162 times 400 to 486. Well, every single time in this pattern we're multiplying by 3, so our common ratio is 3. Now, a sub 3 is asking for the third term, so we want to count terms. 1, 2, 3. The third term is 18. All right, now, a sub 8 is a little bit different. The reason it's different, if you count the pattern, we have 1, 2, 3, 4, 5, 6 terms. So we only have 6 terms, but we're looking for 8. So first we have to find the 7th term, then the 8th term, and then we can complete the pattern. So if we find the 7th term, we have to do 486 times 3. And if you do that, you get 1,458. Well, that would be the 7th term. Now we need to get the 8th term, so we need to multiply that by 3. If you multiply 1,458 times 3, you end up with 4,374. So the 8th term in this pattern is 4,374. Now, the formula that we use for geometric sequences is an explicit formula, and it is a sub n is equal to a sub 1 times r to the n minus 1 power, in which a sub 1 is the first term and r is the common ratio. Now, you don't need to memorize this formula. This formula will be given to you anytime you need to use it. You just need to know when and how to apply it. Okay, so now we want to write the explicit formula for this sequence. -5, -15, -45, -135, -405. Pause the video for a moment, see if you can figure out a sub 1, r, and then if you can plug in the numbers in the formula. Okay, well, a sub 1 is the first term in the pattern, and the first term is -5. The common ratio is the number that you multiply by to get to the next number. In this pattern, we've multiplied by 3 with every problem, with every number. So the formula that we would use for this pattern is a sub n is equal to, the first term is -5, the common ratio is 3, and it would be to the n minus 1 power. Okay, now for this one I would like you to pause the video and see if you can complete and find all the pieces that we're asking you for. It says write the explicit formula and the given terms for the following sequence: 4, -8, 16, -32, 64. So pause the video and see if you can find those numbers. Okay, a sub 1 is the first term. The first term is 4. The common ratio on this pattern is a little bit trickier. You're taking 4 times something to get negative 8. Then you're taking negative 8 times something to get a positive 16. Well, in order for the signs to be changing, you have to be multiplying by a negative. So we know that this is a negative something. And then 4 times what is 8? The answer is 2. 8 times what is 16? The answer is 2. So the common ratio here is negative 2. So the formula that we're going to use is going to be a sub n is equal to the first term times the common ratio, which is negative 2, to the n minus 1. Remember, when you have a negative number raised to a power, that negative number must be written in parentheses. Okay, now we need to find a sub 6. So a sub 6 would be equal to 4 times negative 2 to the 6 minus 1 power. And now, if we complete this pattern, it would be 4 times negative 2 to the 5th power, negative 2 to the 5th power is 32, and it's negative 32 because there's an odd number of negatives. And then if you multiply that, you end up with a negative 128. Now, in order to get the 8th power, we substitute again, and we end up with 4 times negative 2 to the 8 minus 1 power, which is equal to 4 times negative 2 to the 7th power, which is 4 times negative 128, which equals negative 512. Okay, we have now completed and found every number that we've asked you to find. It completes our video for today. I hope you understood what you're doing, and we will go over this in class tomorrow. Have a great day.